Right then, question 25. This is the penultimate one that I want to do. We are given that x is sec squared of 3y. We've got to find dx by dy. So we don't need to do any adaptations to this at all. We just need to differentiate this with respect to y. One thing I want to point out here is, you know, when you learned about implicit differentiation and we said when you differentiate something with y, you always write dy by dx after it. You don't have to do that unless you're doing dy by dx. But because we're doing dx by dy, it means we just differentiate this normally, for want of a better phrase. With respect to y is the proper phrase that we use. So here we go. Part A, dx by dy. Let me just let's write that here, shall we? Just for clarity. So dx by dy, first of all, we're going to write this as sec of 3y squared. So we are going to use the chain rule, cover this over, bring the power down, reduce it by 1, so 2 lots of bracket to the power of 1 multiplied by the derivative of brackets. Now the derivative of sec is sec tan, so we've got sec 3y tan 3y, that's in your formula book, but you have to multiply it by the 3, don't forget, because of the chain rule again. So we've got like a dual application of the chain rule there. Now that would get you full marks because you're not asked to put it in any particular form other than in terms of y, so we've done that. But if you were asked to tidy it up, you would do this. 6 sec 3y times sec 3y is sec squared 3y, and then tan 3y there. So that would be a better version of the answer, but the first one's absolutely fine. Now, B. Hence show that dy by dx is 1 over 6x, x minus 1 to the power of half. So they want dy by dx. Let's reciprocate first of all. Dy by dx is 1 over 6 sec squared 3y tan 3y. Now, sec squared 3y is x, so we've got 1 over 6x and then tan 3y there. So I've just replaced this with x first of all. Now I need to get rid of this tan and get that in terms of x, but what I'm going to do is use the identity that we've been learning about this year, and that's that 1 plus tan squared a is sec squared a. Take the 1 over and then square root. So let's put that over here now. So the square root of tan a, this is tan a, so the square root of sec squared a is 3y, minus 1. But just like before, sec squared 3y is x. So we've got 1 over 6x root x minus 1, and they've just written the root as a power of a half there. So 1 over 6x and then x minus 1 to the power of a half, and I've shown it, so we're all good there. Part C, got to find the second derivative now. So let's write down our first derivative again. And there's loads of ways to do this. You could write all of this to the power of minus 1, and then you'd end up having to use the product rule, but because it's in a fraction, I'm just going to go straight to using the quotient rule and keep it as a fraction. So we'll call this bit u, and we'll call this bit v. Let's come to an aside over here. U is 1, so u dashed is 0. V is 6x multiplied by x minus 1 to the power of a half. So v dashed is, we've got to use the product rule now. I've already used u and v, so I don't want to use u and v again. I'm going to use different letters. I'll call this p and I'll call this q. And I'll do a second sub-aside, or an aside 2 if you like. And we've got p is 6x, which means p dashed is 6, and q is x minus 1 to the power of half, which means q dashed is half x minus 1 to the power of minus half multiplied by the derivative of x minus 1, which is just 1. So that stays like it is. So coming back over here, we've got pq dashed plus qp dashed. So 6x times by a half would be 3x multiplied by x minus 1 to the minus half. That's the first bit, pq dashed, plus qp dashed, which is 6x minus 1 to the power of a half. Now, coming back over here then, the second derivative using the quotient rule, vu dashed minus uv dashed over v squared, always starting with the v here. So we've got all of this v multiplied by 0, so that's just 0, take u times by all of this. So let's put it in a square bracket because we're taking 1 times all of this. 3x, x minus 1 to the minus half, plus 6x minus 1 to the power of a half, all over v squared. So that is square the whole of this, so we've got 36x squared, and then squaring a power of a half is just going to give you a power of 1, of course, so that's x minus 1 like that. Now we need to tidy up the numerator. So what do I notice first of all about the numerator? Well, I can obviously get rid of the 0, and the fact that we've got a minus and 2 terms there means I can make them both negative. Do I want to do that yet? No, I'm going to keep that out there for a moment. What I am going to do is factorise the numerator here because I've got this shared bracket. So I am going to take out a 3, obviously. Let's put the 3 out the front. Try again. Minus 3. So I've just brought 3 out of here and I'm going to take 3 out of there. So we're left with the x here. I'll do it in stages for you. X minus 1 to the minus a half, and then plus 2 x minus 1 to the power of positive half, all over, same on the denominator. Now the good thing about that is the 3 there cancels with the 36 to give us 12 there. So next we need to deal with these x minus 1s. When you factorise and take something out, you always take out the lowest power of each of the instances of what you're trying to factorise out. So I'm going to take out x minus 1 to the power of minus a half. So I've got minus, and then I've got x minus 1 to the power of minus a half. And then in my square brackets, I've taken out all of that, so I'm just left with x in the first term. And then in this term, I've still got the 2, but here, if I factorise something out, I divide each term by it. So I've divided this term by itself, which meant I just had 1. Divide this term by x minus 1 to the power of minus a half. When I divide, I subtract the powers. So I've got half minus minus a half, which is half plus a half, which is 1. So I'm left with x minus 1 there. All over 12x squared x minus 1. Now this is going to be quite easy to simplify and tidy up now, because here I'm going to tidy up the square bracket. X plus 2x is 3x, and then I've got a minus 2. And I've got a power of x minus 1 in the top and the bottom. So to simplify that, because we're dividing, I'm going to subtract the powers again. So I've got minus a half. Let me write it down here so you can see what I'm saying. The powers of x minus 1. We've got minus a half, take 1, which is minus 3 over 2, which is the same as a power of 3 over 2 in the denominator in the bottom of the fraction. So keep your minus here. Keep your 3x take 2, but then in the bottom of the fraction we have got x minus 1 to the power of 3 over 2. That's the same as x minus 1 to the power of minus 3 over 2 there. So finally, that is its simplest form. The only thing I don't like is the fact that I've got this minus outside of a bracket. So if I multiplied that minus in, it would just become a negative 3x and a positive 2. So I've got 2 take 3x over 12x squared and x minus 1 to the power of 3 over 2, and that is absolutely its simplest form. I can't go anywhere else with it, and we're done.